So we're in Unit 9, um, Lesson 6. I know this says Unit 6, but remember we are on a different set, so we should be on Unit 9, not Unit 6. So iPads, you can go ahead and enter this into your iPad. You can follow along with the video and write on the paper. Just take a picture onto your iPad. So quadratic equations, click here. Once you do, it'll look like this. We've done this, we've done this, we've done this, and we've done this. Now we are here. Quadratic formula. So quadratic formula, click on it. Look at this beautiful picture. Okay, completing the square. This is a little bit of a review, and based on completing the square is how we get our quadratic formula. Okay, so it says on slide 1, so on your paper, slide 1. So everything you're writing here should be on slide 1 of your paper. You know how to solve this quadratic equation by completing the square. Look at this quadratic equation and part of its solution by completing the square. Okay, so explain why this portion was added to both sides. Okay, so let's look at this, click on this, and look like this. So it's talking about step 5. Okay. So here's our equation. 3x cubed. So let's look at the original equation first, and we'll see how that affects how it gets to step 3. Okay, so how we got to step 3, a lot of us might not remember, so I'll review that a little bit. So if this is our original equation, I'm going to do all the steps up to step 3. So what we do first is we have to divide everything by 3. So we have to divide everything by 3 in order to get this leading coefficient to be a 1. So remember, our primary goal is to make this one into a 1. So these cancel out and we get a 1x squared. That's what we wanted. And we have plus 7 over 3x. And then we've got 1/3, positive 1/3. And that all equals 0. Because 0 divided by 3 is 0. Now we're going to move this 1/3 over, minus 1/3 and minus 1/3, and we will get x squared plus 7 over 3, and that equals negative 1/3. And we have to add this number here. We have to add this number, we have to add this number. Okay, so remember it's asking us, so this kind of looks like step 3. X squared plus 7/3 x equals negative 1/3. That looks like what we have here, x squared plus 7/3 x, I forgot that x, plus blank. Now in this blank space, they added this 7 over 6 squared. And the question that is asking us is, where did this come from? Okay, so that is our b value, because we've got our b value right here. Okay, if that's our b value, it should be 7 over 3 divided by 2. Okay, now we usually do this, 7 over 3, and we'll divide by 2. It's the same thing, I just wrote it sideways, side by side. So let me get rid of that. And if that's 2 over 1, which is a 2, I'm actually going to change this one and flip it over and have 7 over 3 times 1 over 2, and I can multiply straight across 7 over 6. So this becomes actually 7 over 6 squared. Okay, now we need this number here exactly in order to give us our perfect square. So I'm going to do it to both sides, 7 over 6 squared. Now, like I said, we add this number. Okay, this number is added. 7 over 6 squared is added in order to factor two identical binomials. Okay, What that means is when I factor this out, I'm going to have two things that are exactly the same. It's going to equal whatever this is. Okay. So according to our work here, this is 7 over 6 squared. Okay. So this is step 5, and that equals 1/3 plus 7 over 6 squared, and then you solve the rest of this. Okay. Now, slide 1 is only asking us why we added this number. It's not asking us to solve it, but I'm going to solve the work anyway so you can see what it looks like. Okay. So it looks like I'll have x. I'm going to do this one right here. X, because I just did this part, and I'll continue from here. Okay. Okay, so I continue this down. I squared the top, I squared the bottom. I got 49 over 36. I'm going to add these two together. Negative 1 over 3 plus, there should be a plus here, I forgot the plus, plus 49 over 36. Okay, and these need to be common denominators, so I'm going to multiply this by 12 over 12, so that way we can get a 36. So negative 12 over 36 and positive 49 over 36. Combine these two, 49 minus 12 is going to be 37, I believe. 49, yeah. So I should have 37 over 36 is equal to x plus 7 over 6 squared. I'll square root one side, I'll square root the other. This side is squared. I'll square root this side, and lucky for me, they're opposites, they go away. X plus 7 over 6 equals the square root of 37 over 36. Okay, now this is not looking pretty. So we'll just keep going. I'll square. This should be x plus 7 over 6 is equal to the square root of 37 over 6. Now, the nice thing about this is that the bottom one was square rootable, so I'll leave it as is, and I'll have two answers. I'll subtract this one here, 7 over, let's write two answers. X plus 7 over 6 equals positive square root 37 over 6, and I have a negative answer. X plus 7 over 6 equals negative square root 37 over 6. I'll solve each one. Minus 7 over 6 goes away. Minus 7 over 6. I can combine these two straight across. They have the same denominator. So x equals negative 7 plus square root 37 over 6, because the denominators are the same. And I'll do the same thing over here. Minus 7 over 6 minus 7 over 6. Let's go away, and we'll have x equals negative 7 minus, that's this one right here, square root 37 over 6. Those are our two horribly ugly answers. Okay, slide 2, math mission. On your paper, there are two things here. It says what it says and what it means. Do the same thing here. What it says, and you're going to write this over here and what it means. And you're going to write that on this side. Okay, so what it says, you're going to write this, and what it means, we should be writing something like this. Using the quadratic formula, comma, identify where the roots, solutions, x-intercepts, intercepts, and zeros. Zeros are by plugging in the A, B, and C values. And simplify. Ta-da! Okay, so use a quadratic formula, but that's kind of like a general statement. What we're actually doing is we're doing actually all of these things. Okay, so two things you should be writing down. Okay, slide 3 says complete the table. It's work time. Okay, so there's a table here which I'll expand for you in a second. Let's read what it's asking us to do. It says complete the table to algebraically. Okay, algebraically means basically use some common sense. Okay, think about it. Just think. Don't ask and wait till someone tells you all the answers. Derive, that means kind of like be a detective. The quadratic formula. Okay, so we'll copy this into our notebook. And lucky for you, I did that. Look, it's right there. Okay, so you're going to fill this in just like I'm going to fill in this one. Okay, so example. Here's our example. That's the one we did for A. General equation, what and why. Okay, so we're going to explain what's going on here. Okay, so what I did with the table is I took a little section of the example. Okay, so I took just this section down here, and I put it so I have some workspace. You can do this on the side. You can copy it down once you've seen the entire thing. Now, what we need to do is we need to figure out what happened between these two steps. Okay. Now, over here, I know that I should probably have this value squared, and that's got to be like right here. Okay. So how did I get that squared factor, this binomial here? Is what I did was I used the Xbox method. So here, I'll say factor trinomials. Factor trinomials. Okay, and we use factor trinomials by using the Xbox, and I'll have 7 over 6 squared, which is 49 over 36, and on the bottom 7 over 3, and the only two numbers that work is going to be 7 over 6 and 7 over 6. Okay, I know it doesn't look like it does. Okay, like that is really, really weird, but this number and this number must be the same, and that number is already given to you. It is this number. Okay, so the top number is this number squared, the bottom number is still the b value, and these two mystery numbers are exactly the same every single time, and it is this number. We've learned that when our leading coefficient is 1, that was our first goal in factoring using completing the square, is that these two will always be exactly the same, and we can skip the box. We can skip the box portion. So we'll have 2 x's, and then I'll have the 7 over 6 here, plus 7 over 6 plus 7 over 6. Okay, and this, since they are rewritten, can be written down once. And we'll have x plus 7 over 6. And since they are exactly the same, we can square it. Okay, so all this stuff here, all this stuff, factor trinomials, you can say Xbox method, whatever you want. You know what, let's ungroup that. And these we can group together. And it's going to magically fit in there beautifully. So all you got to do is shrink your work and squeeze it in there. Okay. Factor trinomials, you might want to write something like Xbox method. That's the same, that's how we did it. That's horrible. Xbox method. That's beautiful handwriting right there. That's some gorgeous, gorgeous handwriting. Squeeze that in. See, that's easy. Totally fit in there. Okay. Oops. So this part, squeeze that in. Ta-da. Maybe just shrink it. Okay. Or write small and neat. Okay. All right. So we've got the example down. And now what we've got to do is work on the general equation. Now, all they're doing is substituting, instead of it being a 3, we wrote an A, which is that A term. Instead of the B, we have, instead of the 7, we have the B term, etc. How do we get this? Well, we divided everything by the A term, okay? And we're going to rewrite this using letters instead of the numbers that we have. So every time I see an A, a 3, I'm going to put an A instead. I'll finish this on the next video.